This is a key to worksheet dealing with topic 4, part C, and again that's the one with on complex numbers. And so basically in these 10 problems you're asked to perform the indicated operations and then you need to express your answers in standard form. Okay, so let's look at number 1. So number 1 we have the square root of negative 25 minus the square root of negative 81. Now remember, when we do these, let me go ahead and take this one off. So when we do these, if you just look at negative square root of negative 25, remember, in your mind, this is what you're thinking of. You're saying, well, the square root of negative 25 is the square root of a negative 1 times the square root of 25. And I know that the square root of a negative 1 is defined to be the imaginary unit I. And I know that 25 is a perfect square, so the square root of 25 is 5, and so this becomes 5i. So again, we tend to put the number I in the behind the 5 here. And so this part here becomes 5i. And then you're subtracting, so notice I put the subtraction symbol, and then you do the same thing with the square root of a negative 81. And so the square root of a negative 81 is defined to be 9i. And so these two terms are like terms, and so 5i subtract 9i is a negative 4i. So that's number 1. Okay, so number 2, we have 5 times the square root of a negative 49 plus 3 times the square root of a negative 4. And so let's look at the first term. So I'm going to go ahead and write that here, 5 times the square root of a negative 49. And you want to think about the square root of a negative 49 like you did with the square root of a negative 25 and also with the square root of a negative 81. So we know that the square root of a negative 49, I can rewrite this as the square root of 5 times the square root of a negative 1 times the square root of 49. And so I get 5 times I, square root of a negative 1 is I, and then times the square root of 49, which is 7, because remember 49 is a perfect square. The square root of 49 is 7. 7 times 7 is 49. And so this becomes 5 times I times 7, which is 35i. So this becomes 35i plus, and then you do the same thing with 3 times the square root of a negative 4. And so if you look at 3 times the square root of a negative 4, that's 3 times the square root of a negative 1 times the square root of 4. So that's 3 times I, because the square root of a negative 1 is I. And then the square root of 4 is 2, so 3 times I times 2 is 6i. So this becomes 6i. And so now I can combine those two terms. They are like terms. 35i plus 6i is 41i. Okay, now let's get number 3. Number 3, I have 3 times the square root of a negative 25 plus 4 times the square root of a negative 9. And we're going to do the same thing. So let's look at the first one. So this is 3 times the square root of a negative 25. So I know that that's the same thing as say, and let me go ahead and write it right here. 3 times the square root of a negative 1 times the square root of 25. So that's 3 times I, and then the square root of 25 is 5. So that's 15i. So this becomes 15i plus, and then we do the same thing with 4 square root of negative 9. So with 4 times the square root of a negative 9, I have 4 times the square root of a negative 1 times the square root of 9. So that's 4 times I, times 3, because the square root of 9 is 3. So that's 12i. So this becomes 15i plus 12i. And so 15i plus 12i is 27i. Okay, number 4. So number 4, we have 4 times the square root of 9 minus 3 times the square root of negative 16. And so if you look at the first one, now you need to be careful because this is the square root of 9, not the square root of negative 9. Okay, the square root of 9, so be careful. So my radicand is positive here. So this is just 4 times 3, which is 12. So that's just 12. So don't make the mistake and say 12i, because that's not 12i. It would be 12i if 9 was negative. Okay, so you need to be careful. Subtract, and then we do the same thing with 3 times the square root of negative 16. And so this becomes 3 times the square root of negative 1 times the square root of 16. So that's 3 times I times the square root of 16 is 4. So that's 12i. So I get 12 minus 12i. Now I want you to notice that these are not like terms. So that's your answer. And you wrote this in standard form. So remember, standard form, a plus bi. So if you go back to your directions, it did say write your answer in standard form. So be a plus bi. Now I'm going to go back and just mention something here. So for the most part, we just go ahead and rewrite as negative 4i. There might be some situations, if it's multiple choice, that you could write this as 0 minus 4i. So in standard form, where a is 0, and then b is, bi is negative 4i. Okay? So just keep in mind that if it's multiple choice, this could be an answer or this could be an answer. But they're both correct. All right, they're both correct. But for this part though, where a is not 0, then you need to put that first. So a and then plus bi, in this case is minus 12i. Okay, so that's number 4. Let's look at number 5. So number 5, we have this. All right, number 5, we have negative 2 times the square root of a negative 81 plus 7 times the square root of a negative 4. So again, let's just look at this one first, this term first. I'm going to go ahead and rewrite it here. So negative 2 times the square root of a negative 81. So this becomes negative 2 times the square root of a negative 1 times the square root of 81. And so this becomes negative 2 times I, because the square root of negative 1 is I, and then 81 is a perfect square. So 9 times 9 is 81, so that's times 9. So this becomes negative 18i. So this part here is going to equal negative 18i. Plus, and then we do the same thing with the next term. So the next term, I have 7 times the square root of a negative 4. And so this becomes 7 times the square root of a negative 1 times the square root of 4. So that's 7 times I times 2. So that's 14i. So remember, square root of a negative 1 is I, defined to be I, and then square root of 4 is 2. So 2 times 7 is 14, so you get 14i. And now notice those are like terms. So negative 18i plus another 14i is a negative 4i. Okay, number 6. So number 6, we have 4 times the square root of a negative 75 plus 5 times the square root of a negative 27. All right, so again, let's just look at the first one. So in the first one, I have 4 times the square root of a negative 75. And so if I break this square root of negative 5 down, this becomes 4 times the square root of a negative 1 times the square root of 75. Now the difference between this one and the rest was that if you look at the others, the square root of 4 is a perfect square. 81 is a perfect square. 16 is a perfect square. 9 is a perfect square, and so on. Now we get to the point where the radicand 75 is not a perfect square. But in the previous courses and in the lesson that dealt with this, you learned how to simplify square roots using perfect squares. So you got to remember that this 75, the square root of 75, the largest perfect square that goes into 75 is 25. So here's what you have. You have 4 times I. Now let's think about 75. So I can rewrite the square root of 75 as the square root of 25 times the square root of 3, because 25 times 3 is 75. All right, so that's what you have to do. So to simplify these square roots, you got to think about, well, what's the largest perfect square that will go to 75? And we always use the largest. All right, and then the reason why you use the largest, if you don't, then you're going to have to simplify this further. And you saw that in the lessons as you prepared for this worksheet. So this becomes now this. 4 times I, the square root of 25 is 5, and then times the square root of 3. And so I'm multiplying these 4 factors together. So 4 times 5 we know is 20. So I get 20. And then here's how we write this. So we tend to put the I between the whole number part and the radical part. All right, so that's how we tend to write this. So write it like this. Now, if you want to write it as 20 times the square root of 3 times I, that's fine, as long as I can tell that that I is not under the square roots. Some students have a habit of not being very careful, and they'll extend the square root symbol to where the I looks like it's right underneath the square root, and then you don't get full credit. So that's why we tend to prefer that you put it between the 20 and the square root of 3 so you don't have that confusion. Okay, so this becomes now 20I square root of 3 plus, and we're going to do the same thing with the next one. So 5 times the square root of a negative 27. So we're going to do the same thing. We're going to say 5 times the square root of a negative 1 times the square root of 27. I know that 27 is not a perfect square, but think about what's the largest perfect square that goes into 27. Well, there are only two perfect squares that go into 27, 1 and 9. So the largest of those is 9. So this becomes 5 times I times the square root of 9 times the square root of 3. And then we know that 9 is a perfect square now, so that becomes 5 times I times 3 times the square root of 3. And so 5 times 3 is 15, so this becomes 15, and then you put the I next, and then you put the square root last. And so that goes here, so that's going to be 15I square root of 3. Now notice those are like terms. Those are like terms because of several reasons. You have an I in both of them, and the square roots are the same. So the radicands of the square roots are the same. They're both 3's. So I have 20I square root of 3's, and then I have 15I square root of 3's. So altogether, 20 plus 15 will give me 37I square root of 3's. Okay, so that's that one. All right, now before I go on, let me make sure I did this correctly. 5 times 4 is 20. Make sure I wrote down the problem correctly. And then, let's see, that's 9, so that's 15, right? Oops. Okay, so I don't know why I put 37. That should be 35, right? Okay, 35. Okay, so let's look at the next one. So this is number 7. So number 7, we have 7 times the square root of a negative 18 minus 2 times the square root of negative 32. And do the same thing. So let's look at this part first. I'm going to go off to the side and look at it. So that's 7 times the square root of a negative 18. So this becomes 7 times the square root of a negative 1 times the square root of 18. And remember, 18 is not a perfect square, but I can simplify the square root of 18 because 9, which is a perfect square, goes into 18 evenly. So I'm going to write this as 7 times the square root of a negative 1 times the square root of 9 times the square root of 2. And so now I can simplify the square root of 9, so it'll be 7 times I times 3 times the square root of 2. And then 7 times 3 is 21, so we get 21I square root of 2. So that's this right here, so that's 21I square root of 2. Minus, subtract, and then you do the same thing with the next one. So the next one is 2 square root of negative 32. So this becomes 2 times the square root of negative 1 times the square root of 32. And again, 32 is not a perfect square, but there are some perfect squares that go into 32, like 1, 4, 16. Use the largest. The largest saves you a lot of work. So 16. So this becomes 2 times I times the square root of 16 times the square root of 2. And so 16, the square root of 16 is 4, so it becomes 2 times I times 4 times the square root of 2. And so 2 times 4 is 8, so it becomes 8I square root of 2. So that's going to go here, 8I square root of 2. And now notice those are like terms because you have I in both terms and you have a square root of 2 in both terms. So altogether you have 21 of these and you're subtracting 8 of these. And so altogether you're going to have 13I square root of 2's. All right, so that's number 7. Okay, let's look at number 8. So number 8, we have this for number 8. right, number 8, we have the square root of 25 times the square root of negative 9. And so we simplify each one first. I'm going to go ahead and do the work here. So the square root of 25 is 5 times, and then the square root of a negative 9, remember, is just 3i. So this is just 15i. There's your answer, 15i. Okay, number 9, you have the square root of a negative 9 times the square root of negative 16. Now, here's a mistake some people will make. So, and you got to be careful. You do not do this. Don't multiply the radicands first. And the reason, if you remember your lesson, is that the only time you can multiply, when you're dealing with square roots, the only time you can multiply the radicands is if both of the radicands are positive, or one's positive, the other one's negative. If they're both negative, you're not going to get the right answer. Because see, if you multiply those, a negative times a negative is a positive, so you're going to end up with a positive number with no I. And watch what happens. So you're going to have square root of a negative 9, we know is 3i times, and then the square root of negative 16 is 4i. And then remember, this is 3 times 4 is 12. I times I is I squared. I squared is negative 1. So this is 12 times negative 1, which is negative 12. And that's the answer. So if you had multiplied those out first, the radicands, you would have gotten a positive 12, which is incorrect. You're supposed to have a negative 12. So just be careful when both the radicands are negative. So that's why you'll notice that I did not multiply these out together first. I just went ahead and simplified each one first. Okay? All right, and then finally, number 10, we have negative 8 plus the square root of a negative 32 divided by 6. Now you're going to see this again when we talk about using a quadratic formula. So you're going to have these again. It'll look like these again when you use a quadratic formula. So what I would do first is I would look at the square root of negative 32 first. Let's simplify this. So let's go off to the side and think about how to simplify this. So we know the square root of negative 32 is defined to be the square root of a negative 1 times the square root of 32. And we know that there is a perfect square. In fact, there are several perfect squares that goes into 32, the largest of which is 16. So this becomes I times the square root of 16 times the square root of 2. And so the square root of 16 is 4. So this is I times 4 times the square root of 2. And again, let's put the I between the 4 and the square root of 2. So that's 4I square root of 2. So that's going to go here. So this becomes negative 8 plus 4I square root of 2 divided by 6. And remember, the direction says put this in standard form. So let's rewrite this. I'm going to rewrite this as negative 8 divided by 6 plus 4I square root of 2 divided by 6. But you need to simplify. So negative 8/6 reduced is negative 4/3. And then 4/6 reduced is 2/3. So this is 2I square root of 2 divided by 3. And so that's your answer. Okay, so that is the key to the worksheet dealing with topic 4, part C.